Using similar figures, part 2. So most of the time when you're using similar figures, you don't automatically know that they're similar, but in some cases when you do, you can go ahead and look and set up proportions to see what the different sides are that are not listed. So that's what we're going to do with this example here. So if you look here, we got triangle ABC over here, triangle DEF over here. So that should be an E. And the first thing you should always do is check the angle measurements, because that's probably the easiest thing to do. So angle A here, 90 degrees. Do we have a corresponding angle? Well, angle D, 90 degrees. That's what the box means. So we're good there. So if we know that these are actual similar triangles, as this problem would say if it was set up this way, then we know that this is 30 degrees. And we look over here and we say, well, that's not 30 degrees because it says 60 degrees. And, well, this looks like it might be the same angle as over here. And since we know they're similar, it has to be. So then the measure of angle E is equal to 30 degrees. And back over here, we don't know what this angle is, but we know that this angle here is for angle F is 60 degrees, so the measure of angle C is equal to 60 degrees. And look, pretty easy to figure out. So now we got our angles down. Most of the time when angles match up, even when you're just trying to prove it, then they will be similar figures. For things like triangles, it's always that case, I believe. So if we look here, now we just need to set up the proportions to see what the sides are, because I'm missing this side and this side over here. So if I look here, 8 to 4, 3 to something, and 10 to something. And I don't know what those are, but I do know that I've got one set that is a proportion, 8 to 4. And then I can just compare these. If I want to figure out what EF is, then all I have to do is I have to say, well, 10 is what it would be over here. And that corresponds to the 8 over here for the larger triangle on top. So now I'm going to call this value X. So I just do 4 times 10. That's going to be 40. That's equal to 8 times X. So X is just going to be equal to 5. That's just cross multiplication. So then I know over here, this value here is going to be equal to 5. And then the same thing should hold true, that this is double the size of that. So I might just be able to figure that out in my head that this is going to be 6, but just to test it, we'll set it up again, 8 over 4, because that's the two sides that I know that match up, that I have measures for sure. And now I have 3 is down here. I'm going to say this is Y. So then it's 24 is equal to 4Y. So Y, just like I said, is going to be equal to 6. Now, it can be useful with similar figures for things like shadows and measuring things from distances that you don't actually know what the height is, because you can figure out the length of a side, and then based on if you put something in front of your eyes that blocks it out, like your thumb or something like that, then you can figure it out, if you're careful enough, how high something is. And so that's kind of how sometimes the math problems are set up. But for an example here, a 5.5 foot tall person has a shadow that is 3 feet tall. A nearby tree has a shadow that is 21 feet. What is the height of the tree? So the shadows should, the position of the sun should be the same. So therefore the shadow, it will form an actual triangle here from the position of the sun. So if I look here, 5.5 feet that's the height of the person, and this is the shadow length. And so if that's the case, then since the sun's far away, that this should be set up the same sort of way, like a big triangle here. And the nearby tree is 21 feet, the shadow is. So how tall is the tree? And then I have the value of x up here. So I just do cross multiplication again. 21 times 5.5. That's going to give me, let's see here, that's 5 times 1 is 5. 5 times 2 is 10. And then over here, 5, remember now it's by the 50, not by the 5. So then that's going to be 5 and 10. So my total amount here is going to be 5, 5, 1, 1. So, and then I've got to add that decimal point right there. So the value is I just cross multiplied this times this, and now I have to do this times this. So it's going to be 115.5 is equal to 3x. And I divide 3 into this, and I know actually if I remember my laws of divisibility tests, then I know this can't go in there automatically because this all adds up to 6. 1 plus 1, 1 plus 5, and 1 plus 5, that's going to be 12 total. So this is 2, 7, 12, so I know 3 will go into there. So it should be a nice even number to be divided into. So it's always helpful to remember those little tricks. So, does 3 go into 1? No. Does 3 go into 11? Yes, it goes in 3 times. Does 3 go into 25? Yes, it does. It goes in 8 times. Remember, I got to anchor that decimal as well. And then I bring down the remaining 5, and I've got 15, because that leaves me with nothing there, so this is going to be 5 up here. So the height of the tree, the value of x, is going to be equal to 38.5 feet. And that more or less makes sense because it's substantially taller than the shadow is, and the shadow is 21 feet. So we're done.